increase in the number of drone attacks and the harm caused to people and infrastructure has led to talk to development of a stealth drone named Ash. This talk was put into reality when the drone's deal was signed and Ash was finally developed over the course of last year. This drone was designed to investigate the weaknesses of the current anti-drone systems by focusing on how to evade two of the drone detection techniques, which are optical detection and radio frequency detection. This drone has shown many capabilities, from being able to fly in Wi-Fi mode, GPS mode and the RF mode. The drone's flight control is Navio 2, which is attached as a hat to the Raspberry Pi. The drone also has an external GPS, SE100, uses LiPo battery and is equipped with motors and propellers to take flight. The drone was calibrated and tuned accordingly to make sure that the flight is smooth and the drone's behavior is stable and controlled. To evade the RF detection, the drone was functioned to take autonomous flight by following the mission using the GPS. As well as that, the drone can evade RF detection by communicating at 915 MHz instead of the conventional 2.4 GHz drone communication. To evade the optical detection, the drone was camouflaged by placing a hot air balloon envelope on top of it. In the Wi-Fi mode, the transmitter would communicate with the receiver and fly on different flight modes. The different flight modes tested with this mode was Stabilize, Auto and RTL. For the GPS mode, the drone was able to hold its position and reach the desired altitude. For the RF mode, the drone was able to communicate with the ground control station using LoRa module and receive the data sent by the controller. If the received value was 1, the motor spun for 10 seconds, and if the received value was 0, the motor spun for 5 seconds.